Hello there everyone, and welcome to the first session in the course where I'm actually going to be teaching you some maths. For those of you who haven't seen me before, I'm Melissa Lieberman, the in-house maths teacher at ICS Learn, and you can email me if you've got any questions about maths at mathsteacher@icslearn.co.uk, or give me a ring at my desk during office hours 0800 092 0070. So I'm going to cover quite a lot today. I'm going to cover basic whole number calculations, which will include calculating with negative numbers and also order of operations. Now, these are ideas that you will meet in almost every topic throughout the course, so don't panic if you can't master some of these ideas right now. I'm covering a lot, and most of this stuff is things that most people should know before they come to the course. Possibly negative numbers is tricky for some people, but mainly for GCSE maths you need it for algebra. So don't panic if you can't do long sums with negative numbers in. The reason behind it is so you can do work with graphs and things like that later on. Okay, so as you work through these online sessions, whether you're watching it live or whether you're watching it as a recording, it's a good idea to write everything down so that you can refer back to it later on as you go through. So if you're using it for revision, it will also help you to learn the information. Maths isn't something you should just sit down and learn passively. It's something that you need to work through to help you learn it. If you're watching the recorded versions of these, it might help for you to pause the recording at intervals so that you can either try the questions before you reveal the answers, or also because sometimes it might go a little bit quickly for you. Okay, so those of you that are here live, there's quite a few people here, so do feel free to introduce yourself in the chat box there while I'm going through the introduction slides here. So if you want to say hello in the chat box, there's quite a lot of few people watching live. So, quick overview of what I'm going to go through today. So I'll look generally at adding, subtracting, multiplying and dividing, what many of us consider the things that make up arithmetic in maths. I'm going to go through the method of long multiplication. There's lots of different methods, but I'll show you the two most common ones. We'll look at short division, because you do need to be able to do that. How to tackle wordy questions. We'll have a little look at negative number arithmetic, and then also how to do operations as in adding, subtracting, multiplying and dividing in the correct order. Some of you might know this as BODMAS or BODMAS. Nobody saying hello in the chat box yet? Keeping my eye on there, so if there's anybody watching live, just say hello in the chat box just so that we know that you're there. I think we've got a few shy people. So first of all, the four operations, we call them, of arithmetic: adding, subtracting, multiplying and dividing. So these are the things that you will have learnt probably as a very young child from the very first days of learning maths. And they really form the basis of all arithmetic that you will do. So the four basic operations then are addition. Now it's important to know the kind of words to look out for when you're dealing with wordy problems. So things that show that you might need to add are things like add, sum. So if someone says, what is the sum of these three numbers, it means what are these three numbers added together. You might see plus, you might see increase, so this is increased by this, that's a clue that you need to add. What's the total of all of these numbers? Anyone got any other ideas or words that you might see for add? Feel free to suggest them in the chat box. So yeah, look out for those that kind of language in problems. Then we've got subtraction. Lots of words for subtraction. Anyone want to suggest any? So things like minus, less. So this is 5 less than this. It means you have to subtract 5. The difference. So if I said to you, what is the difference between 20 and 15? I'm asking you to subtract those two numbers. Decrease means to go down, so you might decrease a number by 20. Let's take 20 away. Take away, we use that quite a lot in English, so 5, take away 3, subtract. Also deduct, so if you deduct an amount, you take it away. We've also got multiplication, or times. So these are the different words. Multiply. Product is one that comes up a lot, so if someone says, what is the product of 5 and 7? It means what are 5 and 7 multiplied together. Times, we say that a lot. We say, what is 5 times 3? That means multiplied by. And lots of, that's another word that you might hear a fair bit. Just turn on my pointer tool actually. lots of. So you might say, what are 7 lots of 8? So 7 times 8. And you should try to learn your times tables. It will help with division if nothing else. You do have a calculator in 2 of your exam papers, but there's 1 exam paper where you have to do some non-calculator work. I'll give you some tips for learning your tables in a minute. So lastly, we've got divide. Now, division is the thing that most people find the most difficult. You kind of have to use reverse multiplication. So to do division well, you really do need to know your times tables. So words you might come across are division, divide, quotient. So if someone asks you for the quotient of 2 numbers, the quotient of 20 and 4 is 5, one divided by the other. Goes into, so how many times does 3 go into 21? That's the same as saying 21 divided by 3. And how many times? So I've just said it that way as well. How many times does it go into? Another word to look out for is share. So if something is shared between, if you're given an amount of money and it's shared between 3 people, then that means you need to divide by 3. Especially if it's shared equally, that's important as well. So an amount is shared equally to divide. Okay. Now, if you are not sure about your times tables, one way would be to draw out one of these multiplication squares. You only need to know times tables up to 10 times 10, because beyond that, you can use long multiplication or add 2 related facts together. So, for example, to work out 12 times something, you would work out 10 times the number, 2 times the number, and put the 2 together. So you know up to 10 times 10. And you actually only need to know half of these as well, because things like, if you learn 3 times 5, then you've also learned 5 times 3. So they're swapped around. I'm going to give you some tips here. So if you want some tips for learning your times tables, I'm just going to paste this into the chat box. Now, if you're watching the live version, you can click on that and it will open up in your browser window and you can take a look at it later on. But I will also send you an email after the session with all of the links in it. So don't worry too much about the links that I'm putting in there. They're really more for the people that are watching the recorded version. I'll email them to you later. So there's some good tips on there about how to go about learning your times tables if you don't know them already. Let's have a look now at long multiplication. So long multiplication means when you're not using your times table so much, but multiplying by a 2-digit number or a 3-digit number. And you might have questions in the non-calculator paper that ask you to use this long multiplication. Now, it doesn't matter what method you use. So if you come from a different country where you've learned a different method, that's fine, as long as it works and gives you the right answer. Also depends on how old you are. If you're about my age, I learned using this traditional long multiplication method, which I'm going to show you right now. But if you're younger, you might have used the grid method at school, which is also a good method. And I'm going to show you both, not to confuse you, but so you can use the method that you feel most comfortable with. You can choose which one makes most sense to you. So the traditional method of long multiplication works something like this. So supposing we've got something like 387 times 54. What you would do is put the bigger number, the 3-digit number on the top, and the 2-digit number underneath. And what this method essentially does is it goes through digit by digit multiplying. And what we're going to work out here is 4 times 387, and then 50 times 387. And the way we work out 50 times 387 is we put a 0, and we just move everything along one place and multiply it by 5, and then we add the 2 things together. And I'm hoping that you're already familiar with short multiplication, which just involves taking the digit at the bottom and multiplying from the units to the tens to the hundreds all the way across. Now, this is normally taught at primary school level, so I'm not going to go into too much detail. I'm hoping that you've done it at some point past. If you haven't, I'll give you some resources at the end that you can use to practice this. So the first step is lining it up. Lining up the units, tens, hundreds, if you need to. You won't really get anything much more difficult than this in the exam, so no more digits than that. So let's go through step by step and see how this is done. So the first thing we need to do is start with the 4 in the 54 and multiply each digit in turn here. So we work out 4 times 7. Hopefully you know your times tables. That's 28. So we put the unit in the units column and we carry the 10. So we put the 8 here and we carry the 2. This will take a bit of practice if you haven't done it for a while. So write down 8 and carry the 2 the 10th. So I'm going to add that on in a minute. Next, we need to work out 4 times 8. So 4 times 8 is 32. I'm not great on my times tables either. The way I would quickly do that if I wasn't sure is I would double 8, which is 16, double again. Okay. Then add the 2. So 32 plus 2 is 34. So we're going to write the 4 here. We're going to carry the 3. Some people carry it up here, but it doesn't really matter where it goes. So carry the 3. Next, we're going to work out 4 times 3. That's a bit easier. 4 times 3 is 12. Then add on the 3 that you carried, and that will give you 50. We'll just put that in there. There's nothing here, so we can just put the 1. It's just be written down directly. Okay. Now, this number here, 1,548, is 4 times 384. So I've done that bit. Next, I'm going to work out 5 times 387, but with a 0, but it's actually 50. So 50 times 387. So the first thing to do is put down a 0. Put the 0 in there. Then we're going to go through as we did before. 5 times 7 is 35. So put down the 5, carry 3. 5 times 8. 5 times 8 is 40. Plus the 3 is 43. So put down the 3 and carry 4. 5 times 3 is 15. Plus 4 is 19. So we just write that in there like that. And then the last step is to add those two numbers together. So add those together. We're just adding these two numbers here together. So 8 plus 0, 8. Again, start with the units and work along. So 8 plus 0, 8. 4 plus 5 is 9. 5 plus 3 is 8. Not carried anything yet. Here we do. 9 plus 1 is 10. So put down the units for 0, carry 1. And then 1 plus 1 is 2. So that's the final answer. It's quite a big number. To help you read the number, count 3 digits in. 1, 2, 3. You can put a comma here if you want. We do that in the UK. In some countries they don't use a comma, so it can get confusing, so you don't always need to do that. So this number is read as 20,898. So that's the answer. Okay. If you've never done that method before, you don't need to. You can use a different method. So for example, you might use this grid method. Let's have a look at how this works. So this is doing the same thing, it's just breaking the numbers up a bit more. So what we do for this method is we do something called partitioning. So we're going to partition them. So for example, 387 is 380 and 7. Well, it might sound obvious, but it would look something like this. So if we split the numbers into separate tens, hundreds and units, then we've got 300 plus 80 plus 7. How about this number? How can we split that up into tens and units? Well, this number, the 5, is 50, and the 4 is 4. So this is 54. And then what we're going to do is put these numbers around a grid, and we're going to multiply each of them by the other. So we've got 387 times 54. And then what we do is in each of these rectangles in the grid, we're going to multiply the numbers at the top of the column and the end of the row. So in this box, we're going to work out 300 times 50. In this box, we're going to work out 80 times 50. In this box, we're going to work out 7 times 50, and so on. This one will have 300 times 4. So you're only going to need to use your basic multiplication facts and add in the correct number of zeros. So let's see how this works. So in the first box, we've got 50 times 300. So what we do is 5 times 3, which is 15, and then count the zeros. 1, 2, 3 zeros. So 1 5 followed by 3 zeros goes in there. In this next box, we've got 50 times 80. So we work out 5 times 8, that's 40, and then another 2 zeros. So there'll be 3 zeros altogether because we've got the 0 from the 40 and then another 2 zeros here. In this box, we're going to do 7 times 50. So that's the same as 7 times 5, which is 35, and then add on 0. Because it's a little bit like 5 times 10 times 7. That's where that 0 is coming from. 12 with 2 zeros. 3 times 4 is 12, so 1,200. In this box, 4 times 8 is 32, plus a 0, 320. And in this box, it's just 4 times 7, which is 28. Then to work out the calculation, we need to add these 6 numbers together. Now you can either add all 6 numbers together in a row, it should be quite easy because of all the zeros, or you could add it up in stages. You could add together these 3, then add together these 3, and then add the 2 together, however way you feel more comfortable. So if we just add all of these together, 6 numbers, as you can see there's lots of zeros here, so it's easy to go through and add it up. So if we add all of these together, go through the units first, then the tens and then the units, then the hundreds and the thousands, we get exactly the same answer. And you can check it on your calculator. So if you want to practice lots of these, you could make up some questions, work them out, and then check them using your calculator. You get 20,898. So those of you watching live, just so I get an idea, what method do you think you would prefer? What method would you find the easiest? If you think the grid method is easier, put a G. If you think the more traditional method is easier, put a T. That will give me an idea. If you're in a traditional, my kids all use the grid method at school, and when I try to teach them the traditional method, they go, oh no, I can't do it that way. I'm used to doing it the grid method way. So maybe you guys are older learners. Really, I think it just comes down to how you were taught. If you were taught the traditional method and you feel comfortable with that, use that. If you were taught the grid method and you find that easier, use that. There's no right method as long as it gives you the right answer, and that's fine. Another method that you might have met, if you're interested, you don't have to learn it, but you can have a look, is something called the lattice method. So that uses grids as well, but it works with these sort of use of diagonal line through the grids. I've never really used it very much, but it's interesting to see that there are lots of different methods that you can use. And people in other countries might have used this method in school instead. So have a look at that if you're interested. So different ways. You will not be marked down if you use a different method in the exam. If you want to practice some long multiplication, this page is very good. It's from a website called CIMT, Centre for Innovation in Mathematics Teaching, and there's lots of examples, interactive examples and questions that you can go through and practice and check your answers a little bit like the way our website works. So have a look at that if you want to do some practice questions. So the next thing I want to have a quick look at, the other method I want to look at is short division, because you will need to use short division possibly in certain types of questions in the exam. You don't need long division. A lot of students ask me about long division. I've never seen a GCSE maths exam with a long division question in a calculator paper, so you don't need to learn that as a method. If it was, there would be one that you could solve using a different way, so either subtracting multiples or something like that, but as a method you don't need long division. But you don't need short division. So I think of division as the inverse of multiplication, so it's worth practicing your division if you're not confident with it. Let's have a look at some examples. So short division is just when we divide a big number by a single digit number. So for example, we've got here 3,144 divided by 8. How do we work that out? Well, it's set out like this. The number that we're dividing by goes on the outside, so the smaller number usually is on the outside here, and we put the longer number underneath a dividing shape like that. Now you can also, just to point out, this will come up later in the course, a division like this can also be written like this. I'm just going to write straight onto the slide. So there's no reason why you couldn't write this division like this. Divided by 8. That's often used as a notation in GCSE maths. And that is the same, works the same as a fraction. So if you wanted to simplify this division, both of these numbers are even, you could divide top and bottom by 2 and make it into an easier division. That's another trick that we use, and I'll go into more detail about how that works later in the course. Before now, let's just divide it as it stands like this. So how do we do that? Now, for division, rather than working from the units and then working back through to the bigger digits, we start with the bigger digits. So let's have a look. First of all, we say to ourselves, what's 8? How many times does 8 go into 3? Well, 8 doesn't go into 3 any number of times in this context, because 3 is smaller than 8, so we just leave that blank. We can either write a 0 in here, you can if you want, or just leave a space. So think of it as 0 carry 3. So it goes no times, and then there's 3 left over. You could write it like that. Or you could just say, well, it doesn't go into there. How many times does it go into 31? So that's what we do. We go into the next digits. We carry that across. How many times does it go into 31? So you need to know your 8 times tables to work this out. So if you're not sure, you can start going through them and think, well, I know that 4 times 8 is 32. So that's too big. So it must go 3 times. What's 3 times 8? 3 times 8 is 24. So it's 24 remainder 7. So sorry, not 24 remainder 7, it's 3 remainder 7. So it goes into 31 3 times and remainder 7. And then the 7 gets carried along to the next digit along. So I just put my pointer tool back on. So then the 7 gets carried to the next digit along there. Then we need to work out 74 divided by 8. Hopefully, if you know your 8 times table, you know that 72 can be divided by 8 exactly. So if we do 72 divided by 8, it goes 9 times, because 9 times 8 is 72, with 2 left over. So we write the 9 up here and carry the 2 over to here. And then lastly, we're going to do how many times does 8 go into 24? 24 divided by 8. Now that goes exactly this time. So it goes exactly. It goes 3 times. Now, what about if it doesn't divide exactly? There's several different ways of dealing with this. If it doesn't divide exactly, sometimes it depends on the problem that you're trying to solve, whether you write the remainder as a decimal or a fraction. But we'll go into examples like that later in the course. One thing that you can do if it doesn't divide exactly is just add some more decimal points after the number like this. 0, 0, 0. We're not doing anything to change the value of the number by adding zeros on the end. Put a decimal point there. And then just carry on working through until you get your answer as a decimal. So if it doesn't go exactly right, either write the answer as a decimal or write it as a fraction. We don't ever write remainder something in GCSE maths. It doesn't really make sense in this context. Okay, so 397. Happy with that method? It will take a little bit of practice. As I said, don't worry about long division. You don't need to divide by 2-digit numbers for GCSE maths. So it won't come up. If you want some practice questions, I'm going to give you some here. So, as I said, if you're watching live, don't worry too much about these links. I'll email them to you after the session. So this is just some practice of mental division, so practicing dividing mentally in your head. Here are some questions to help you practice all sorts of different ways of dividing. So there's 3 exercises here for you to have a go at. And then we've also got some division problems, so word problems. I think the biggest problem with word problem involving division is interpreting what to do with the reminders. So have a look at that. Okay, there we go. Now, when you're dealing with 4 operations of arithmetic, adding, subtracting, multiplying and dividing, it's unusual in the exam that they'll just give you a sum to do. Usually it will be a word problem and you'll need to decide how to solve it using for arithmetic, so dealing with wordy questions. Don't panic when you see lots of words and information in the question. The skill that you need to learn is breaking the question down into smaller parts and deciding what maths you need to do to work out the answer. So the first step will always be to read the question carefully and work out what bits of maths you need to answer it. So you're going to need to add, subtract, multiply, divide, use fractions, use percentages. So you need to make that decision first. It can help to underline or highlight the information that you're going to need to answer the question. Sometimes they have information in the question that you don't need to work out, and sometimes The information they give at the end is information that you need first. So sometimes when there is more than one calculation, you need to work out what order you need to work it out in. I'll give you an example in a second. And then the last thing is to write the question using maths notation, so in other words, write out the calculations. This is important even on the calculator paper, so even when you're using a calculator, it's important to write down the calculation, work it out on the calculator, and then write down what the answer is at every stage, because you could lose marks. If you get the final answer wrong and you haven't written out your calculation, you won't get any method marks. So in maths, they do award you marks for showing how you work the question out. So make sure you show it clearly. So here's an example from the Summer 2018 Foundation 1 paper, question 10. If you want to pause this right now, if you're watching this as a recording, you can, and try to answer the question yourself. That would be good. So we've got that Tim and 3 friends go on holiday together for a week. So what have we got here? We've got that they go away for a week. Is that going to be important? Might be Tim and 3 friends, so 4 of them together. The next line tells us that the 4 friends will share the cost of a holiday equally. So usually when you see the word share, you think, well, there's probably going to be some division in here. They share it equally with 4 friends. And then we're given the cost of the holiday. We're told the cost of 4 return plane tickets. Doesn't look like they're going to ask us the cost of each plane ticket, so there's no point working that out. So that's information that we don't really need. The fact that there's 4 tickets. £640 for the villa and £220 hire for the week. And what we want to do is work out how much Tom has to pay for his share of the cost. So I'm just going to put my highlighter pen on here. Now it's worth checking when you do the exam whether you're allowed to take a highlighter pen into the exam. Some exam centres are fine with it, others are a bit funny. But if you can use underline things instead. So we're going to have to, first of all, find out the total cost. So we're going to have to add up these 3 numbers, find out what that is. And then we're going to find out what Tom's share is. So we've got 4 people all together, and they're going to share the cost equally. So the first step will be to add those 3 numbers together, and then divide by 4, because there are 4 people. So this is a non-calculator paper. So we're going to add these numbers together. Make sure you line them up, line up the units. So I'm just going to mark that on here. Hopefully this is something that I'm going to go through at addition, because I'm hoping that you're familiar with it. So this is the units. This is the tens, hundreds, and thousands. So going along and adding these up, the first column, the units, comes to 0. Then we've got 8 plus 4 plus 2. 8 plus 2 is 10 plus 4 is 14. Write down 4, carry 1. Then we've got 6 plus 2 plus 2 is 10. Plus 1 is 11. So 1, carry 1. And then 1 plus 1 is 2. So the total cost is 2,140. Don't put units in when you're working out. You don't need the pound signs. Just put the units in at the end. Otherwise it can just confuse the calculation. So the next step is to use short division to divide that by 4. If you're not confident with division, you could also half it and half it again. That would also work. But using traditional short division, this is how you would do it. So you would work out 4 into 21. Now, you should know that 4 times 5 is 20. So that means it goes 5 times remainder 1. So we put a 5. You don't really need a 0 there, just put a 5 there. And carry 1. 4 into 14, that goes 3 times. 3 times 4 is 12, so the remainder 2 gets carried to the next one. And it goes exactly. 4 into 20 goes 5 times. If it hadn't gone exactly, then you could have added a decimal point here and 2 zeros. And that would have given you, in this case it does divide exactly. Actually, you could put the 2 zeros if you wanted to. And you would get a number of pence then if it didn't divide exactly. In this case, it does go exactly. So the answer is that Tim's share is £535. Happy with that? Okay. If you want some more practice questions, there's some in the book. these questions are actually pretty hard, I would say, in terms of the arithmetic that you need to do. It won't be as hard as this in the final exam. The actual arithmetic, the numbers involved won't be as hard as the questions in the textbook. But have a go at those for a challenge. If there's any arithmetic you think that's too hard, just use your calculator, because it's just as important for you to know how to solve the problems, as in knowing what operations you need to use, and using the calculator as it is to actually use a written method to work these out. So I'm completely happy if you want to work some of these out using your calculator, because the arithmetic, as I say, is harder than you would need to do in the actual GCSE exam. If you want to really have a look at how hard the questions are going to be in the final exam, in terms of how difficult the arithmetic is going to be, go to the assessment centre page. I'm going to give you a link here on your course. If you're watching a recording of this, I'm going to add an extra unit shortly, Unit 5, which will have all of the exam papers in it. But for now, they're in the assessment centre page. So go to the assessment centre, scroll down the page. If you go right down, you will see links to 24 foundation tier papers at the moment, but I'm going to add more as the year goes on, and 24 higher tier papers. Have a look at the paper 1s, which are the non-calculator papers. So you can look at the blank question paper by clicking there. You can have a look at the written answers by clicking there. You can also look at video solutions, but don't worry about them for now. So it's worth just having a look through, because that will give you a good idea of what you're working towards, what it is that you need to be able to do by the end of the course. If you look at the higher tier ones, it's actually a lot less arithmetic. It's more algebra and geometry in there, so there really won't be a lot of difficult sums, as it were, for you to do. So just go through and look at all of the ones that say non-calculator, so this one here, and this one here. Okay, and even if you just look at the one with the answers in, that will also give you some idea of how the answers are to be set out. Okay. So, everyone loves negative numbers, I'm sure. If I was to choose any two topics that people always get stuck on when they start the course, and I get loads of questions about these, it would be negative numbers and fractions. So the first thing I want to say is, please don't spend a really long time on negative number arithmetic if it's just not clicking. Go back to it later. You won't be asked to work out any sums with negative numbers in the exam. The reason you're learning it is because you need it for algebra, and you need it when you go on and do work with graphs later on. And we have graphs where the coordinates go into negative numbers, so you need to have a good feeling of how they work. So if it's just not clicking, don't panic. There will be opportunities to revisit it later on. Don't spend too long on it, never in a week anyway. So if you want to practice questions with negative numbers, there's a whole section in your course notes, and there's lots of videos in there as well that I recorded previously. So here's a link to that page, or you can just go into your Unit 1 and find this section at the top on negative numbers. So what are negative numbers? So they're essentially numbers that are less than 0. So for example, here I've written a minus sign in front of the 5, but that's usually read as negative 5. So the sign is telling me that it's a negative number. Numbers that don't have a sign in front of them are positive numbers, but we just don't normally put a plus in front of them, but that's just to tell me. So the minus sign there doesn't mean subtract in this case, it just means that that number is 5 below 0. So it could be negative 5, as in it could be minus 5 degrees. You might owe the bank £5, so it might be a £5 debt, it might be 5 metres below sea level, so 5 less than 0. Other contexts, losses, overdrawn bank accounts. Sometimes when you're dealing with dates around AC and BC, that's another context where you might meet negative numbers. So they do come up. For most people, when they're trying to do problems involving negative numbers, it's easier to think of temperature. So imagine below 0 and above 0 in terms of temperature. So let's see how we add and subtract negative numbers. Sometimes called directed numbers because it's very much to do with direction. Adding means go up the number line, subtracting means go down. So it helps to think of the numbers as positions on a number line. Now you can either think of it as positions going left to right, or you can think of it up and down, more like a thermometer. That helps you to think negative is going down, positive is going up. So if you're ever stuck in the exam, really can't picture what's happening, just draw a number line. So we've got 0 in the middle here. These are what we call negative integers. Integer just means a whole number. These are positive integers. So integer just means a positive or negative whole number. They can be negative as well. So around here you would have negative 4.5. So they can be decimals as well. They're not always whole numbers. But for today we're just dealing with integers, whole numbers. Okay, how do we do arithmetic with them then? So what does it mean? Supposing I've got part A. If you want to answer these, I'll ask you any questions for a little while. If you want to have a go at answering these, just write A, then put your answer. So for part A, we want to work out negative 2 plus 7. What does that mean? How do we do it? Well, the number at the beginning is telling me my start point. So when we've got more than one number, it's important to identify the start point. So what this is saying is I'm starting at negative 2, and then I'm going up 7. So start at negative 2 and go up 7, or 7 jumps up. So lots of people are saying 5, and you are correct if you've put 5. Let's have a look at why that is. So negative 2 plus 7 means I start at minus 2, and then I go up 1, 2, 3, 4, 5, 6, 7. Now, notice that when we're adding two numbers, we can also swap them round. So it's just like 1 plus 2 is then 2 plus 1. If I swap those round, then I would have 7 or plus 7 minus 2. And it gives me exactly the same answer. So sometimes it helps to change the order of the numbers because it makes it easier to work out. So you get the same answer if you start at 7 and take away 2, as you do if you start with minus 2, negative 2, and add on 7. So that's a useful thing to point out. Now how about B? B is a little bit more difficult because we've got 3 numbers in there. We've got negative 4, then we're subtracting 5, and then we're adding 3. So minus 4 is where we start. So we identify the minus 4 here. And then we're subtracting 5, so we need to go down the number line. So if we start at minus 4 and go down 5, like this, 1, 2, 3, 4, 5 jumps like that, that will take us down to minus 9, negative 9. And then we need to add 3, so we need to go 3 up the number line. That takes us to negative 6. That's where we end up. And similarly, you can change the order of the numbers, you would get exactly the same problem. So if I started with 3, and then I went down 4, and then I went down another 5, I would end up at exactly the same place. Minus 4 minus 5 is minus 9. 3, take away 9, doesn't matter what order we do it in, we'll also take it to minus 6. So we can do it in a different order. 3 take away 4 is minus 1, and then take away another 5. So you get the same answer if you change the order. Happy with that? That's basically all it is. Where it gets tricky is where we have to subtract a negative number or add a negative number. And the thing to remember really with these is that the minus sign in front of the number is really telling us that it's a negative number, while this sign here is telling us to subtract. So those two minus signs mean different things. This means subtract, that's the operation. And that means negative, which means below 0. Similarly here, this is add, and this means that this is negative 500, so add negative 500. That sometimes helps to know why we're treating them this way. Now, you probably heard this rule, but when you subtract a negative number, you can combine those two negatives the same as adding, which is taking away a negative number. Now, it takes some people a really long time to get their heads around this sometimes, but I'm going to give you a really good resource that you can use to help you understand. It's like the negative numbers cancel each other out to make a positive. And we put these brackets around the number just to say this is a negative number, but you can take the brackets away if that helps, and then combine the signs. So this is probably the hardest thing you're going to do when adding and subtracting negative numbers. If you add a negative number, it's the same as just subtracting it. So adding a negative number is the same as subtracting that number. And subtracting a negative number is the same as adding it. So we're kind of going down, but then back up again. They cancel each other out. So have a go at these two sums now. How do you work out 7 subtract negative 5? Have a think about what you think the answer is. and then put the answer in the box. Remember to tell me whether you're answering A or B. So type it in the box, what do you think part A is? And then for part B, what do you think -4 plus -9 is? So Helen thinks 13, Stephen 13, Alicia 13. Shall we have a look? So we've got two negative signs next to each other. So we drop the brackets first of all. And then because we've got two minus signs next to each other, that's the same as plus. So 7 plus 5 is 12. Yes, 12. So why does everyone say 13? Or are they answering the second question? I think sometimes people put a number and then everyone copies it. It's definitely 12. I thought I was going mad there. Yeah. I think somebody put 13 and then everyone just copied in a panic. You got the sign right, so that's the main thing. That's mainly what we're testing. Everyone can make mistakes with the arithmetic. Yeah, 12. Thank you. That's quite funny. Part B. Think about it more carefully this time. I know a few people have put the answer. So we've got most people seem to think -5. So let's see how do we work that out. Well, don't know. I think this one has got 13, but it's -13. Let's have a look. So I don't want to try and do it without thinking too hard about it. So yes, 5. Sorry. Yes. Now I'm going the wrong way. Ooh, going mad. So how does this work? So we start at -4, and we're going to add -9. Now adding -9 is the same as subtracting 9. So this is like -4 minus 9. -4 plus -9 is the same as -4 subtract another 9. So this is like, imagine it's -4 degrees, and then it gets another 9 degrees colder than that. So you're going even further down the number line. So that's going to give us -13. So those of you watching live, I think this is going to take a little bit more practice. These ones definitely are a lot more difficult. Take it step by step. If you're using your calculator to check, you have got a minus sign on your calculator, so you can use that to check your answers. If you're just not getting it and you're not sure, have a look at this page from Maths is Fun, because it's got some good explanations. You won't have to answer questions like this in the exam, as I said. It will be in the context of algebra, and sometimes that helps it make a bit of sense. Okay, have a little practice of that, because it is tricky. There's also some videos on the ICS Learn course page, so have a look at the videos on there. This one is about combining signs when you're adding and subtracting integers, whole numbers. And there's also a good exercise here that you can use. But don't spend any more time than this. So work through all of these. Don't worry if it's still a bit fuzzy. You won't actually be asked questions like this in the exam. It will be in the context of algebra. So as long as you vaguely get it, you'll be fine. Now, multiplying and dividing negative numbers is a lot easier, because all you need to do is decide what sign the answer is going to be, and then actually multiply or divide the digits that you're given. So it's a bit easier. With adding and subtracting, you don't know what sign the answer is going to be, because it depends on the size of the numbers, your starting point, how many you're going up or down. With multiplying and dividing, you can just look at the signs in the question, and that will tell you what signs in the answer will. Let's have a quick look. So if it's two numbers and both are positive, the answer will be positive. And if both numbers are negative, the answer will also be positive. So if the answers are the same, if the signs in the numbers are the same, the answer will be positive. For example, if I had -4 times -2, I'd say, well, a minus times a minus times cancel each other out, so it becomes positive, and then 4 times 2 is 8, so the answer is just 8. Similarly for dividing, if I've got -4 divided by -2, these signs cancel each other out, and then I'm just left with 4 divided by 2, which is 2, positive 2. If the signs are different though, so if I've got a positive and a negative number, then the answer will be negative. So 4 times -2, I've just got one minus sign in the question, so there'll just be a minus sign in the answer, so that'll be -8 or -8. And if I have -4 divided by 2, that's a little bit like half of -4, that would be negative 2. So that's minus 2. Don't overthink it. It's a lot simpler than it looks. You just use your intuition after a while. So signs are different, then it's going to be negative. Signs are the same, it's going to be positive. I think the most difficult thing is when you've got two negative numbers like those two, the answer is going to be positive. Two negative numbers cancel each other out. Let's have a look at a couple of examples. So part A. Answers in the chat box, please. Negative 7 times negative 6. What do you think is the answer? Stephen, very quick. So we're just going to copy Stephen. I'm not saying whether Stephen is correct or not. Use no times tables. Yeah. So the main thing I want to check is that everyone's put a positive number. That's the main thing we want to get from. So minus times a minus, negative number times a negative number. The negatives cancel each other out, so the answer is going to be positive. Good. So 7 times 6 is 42. So the answer is 42. How about part B? And we could also write part B like this. So we could also write part B as 45. I just want you to get used to seeing it written in the different ways. 45 divided by minus 9. So we can also write it like that. So first of all, the signs are different. So the answer is going to be negative. So 45 divided by 9 is 5. And we need to have a minus sign in there. So everyone, Fiona and Stephen and Emmanuel, perfect. Minus 5. Good. A bit easier than the previous one. Now here for example A, I've got 3 numbers. I just want to have a look at what happens if I've got 3 numbers. So we've got 3 numbers and they're all negative. Now I know that 2 negative numbers gives you a positive answer. What do 3 negative numbers do? Well, we just do it step by step. So first of all, work out minus 2 times minus 3, and then multiply the result of that by minus 5. So this is the way it works. Minus 2 times minus 3 is 6. So I've got 6 times minus 5. So I've got a positive number times a negative number. Positive times negative gives me negative, and 6 times 5 is 30. So altogether I've got negative 30. Now this might be interesting, I don't want to confuse you though. If you have an odd number of negative numbers in the sum, you're multiplying an odd number of negatives, the answer will be negative as a general rule. So if it's an even number of negatives, the answer will be positive, because every pair of negative numbers cancels each other out. So it's like these two cancel each other out, and then I've got one left over. Does that make sense? That's the way to think of it. Don't worry, you get plenty of practice with this when you do algebra later on. Now how about part B? So for part B, again I've got 3 numbers. So this time I just do it in order working from left to right. 4 times minus 2 is negative 8. And then I've got times negative 7. So this answer this time is going to be positive. Good, everyone has put 56 is correct. 7 times 8 is 56, and the minus times minus gives me a positive answer, 56. Part C, I've got minus 36 divided by 9. So here we've got a negative number divided by a positive number, so the answer is going to be negative. So I can just write down the minus sign. And then 36 divided by 9. Good, Stephen. Anyone else? 36 divided by 9. Try to choose ones that you might not know. Learn your times tables. So 36 divided by 9 is 4. Good, so the answer is negative. And then part D, we've got 2 negative numbers, so the answer is going to be positive. Emmanuel, Katie, good, 6. Stephen, good, 6. Everyone is type 6, well done. And it's positive 6. 2 negatives cancel each other out, which is left with 6. Okay. Here's some good practice questions, but honestly, multiplying and dividing negative numbers is much easier than adding or subtracting them. Have a go at that. Now, one last thing before I let you go. I know this is a long session, but I want you to... there's some practice questions here as well, sorry. So if you want some practice questions from the textbook, there are some here. So this is from chapter 1 on calculations. Just do questions 1 to 5, don't worry about the rest. Let's have a look now at order of operations before I let you go. Now, order of operations is just when we've got more than one thing in the calculation to know what order we need to do it in. So operations are just things like adding, subtracting, multiplying, dividing, squaring, could be considered all square rooting. And when you've got several operations in the calculation, you need to do them in the right order. You might have heard of BODMAS or BIDMAS. Some people find this a little bit confusing, some people it helps them remember. The thing to remember when you're using BODMAS or BIDMAS, which tells you the order that you're supposed to do the calculation in, is that division and multiplication have the same priority and addition and subtraction have the same priority. So it's not that division comes before multiplication, because these are both equal priority, and then addition and subtraction. So what this means is you do the brackets first, so work out any brackets first. O for orders I've never really liked that much. Usually I use BIDMAS, I for indices, but so orders might be things like powers and roots. Then we do division or multiplication. Then we do addition and subtraction, like that. So I'm just saying that these are equal priority. So always divide or multiply before you add or subtract. That's the main takeaway from this, because I think most people know that the brackets will be done first. Sometimes we use brackets to say that. So that's the main thing that you need to remember. So let's have a quick look at an example. So for example, if I asked you to work out 15 take away 8 times 2, what would you give me as an answer? All Katie and Fiona very quick there. And I think everyone's got it right. Now, you might be tempted to say, okay, well, I'm going to work from left to right. 15 take away 8 is 7, and then times 2 is 14. That is not right. That's incorrect, because we need to multiply first. So what you actually need to work out, this is actually 15 take away 8 times 2, and 8 times 2 is 16. So it's actually 15 take away 16. So make sure that you multiply, because multiplication comes before subtraction. So we need to multiply before we subtract. If you take those away, you get -1. Perfect. Everyone will put -1. Okay, here's a more complicated one with some brackets in. So have a go at this. What do you think the answer is? So brackets first. So work out what's in the brackets first. I'm throwing in some negative number arithmetic here just to test you on that too. Bring it all together in one place. So have a go. So 3 subtract 7 times -5 plus 6 divided by 3. Quite a lot going on there. So Katie's very quick with 12 there. Let's see if anyone else agrees. So do it in steps. Don't try to do the whole thing all at once. So do it in steps. So 3 take away 7. So working out that bracket first will give me -4. Then I've got the times. Now I need to do 6 divided by 3 first. So 6 divided by 3 is 2. So it's going to be -5 plus 2. So this calculation is -4 times -3. We've got a negative number times a negative number, so the answer is 12. So brilliant to everyone that put 12, and you got it right. Good. And here's another one. I've got a few more, see if I've got time. How about this one? Now this one looks a little bit different because we've got a dividing line here. So just so you know, when you have a dividing line like this, work out what's on the top, work out what's on the bottom, and then divide the very last step. So it's as if this dividing line works like brackets like this. So we work out what's on the top, work out what's on the bottom, and then divide in the last step. Does that make sense? So let's try this. So on the top we've got 11 plus 2 times 8. 2 times 8 is 16. So on the top we've got 11 plus 16. And on the bottom we've got 6 minus 9. So work that out first. And that gives us 11 plus 16 divided by 6 minus 9. So 27 divided by -3, a positive number, divided by a negative number. By the way, you would never have anything as difficult as this in the exam. I just want to throw in order of operations with negative numbers so you can practice 2 things at once. That's a good thing about maths. You can find lots of different topics in one place. So yes, brilliant. Everyone that's put -9, you're getting the idea now, so you've done really well. Good. That's it. Okay, here's a few more for you to try. If you want to pause, if you're watching the recorded version, you can pause it, try this yourself. So what do you think? Let's see if you can get the right answer first. So no pressure. People who are watching live, just type what you think in the chat box, and then we'll reveal the answer in a second. Yep. Stephen's got an answer there. Shall we see if he's right? So we've got this one. We've got 2 times. We do the bracket first. 8 plus 4 is 12. So 2 times 12. We do multiplication before subtraction. Or we would probably do it anyway first because it comes first in the calculation. So we've got 8 plus 4 is 12. 2 times 12 is 24. And 24 minus 7. Brilliant. Helen and Fiona and Emmanuel, you've all got it right as well. 70. Okay, so another one. Next one we've got the dividing line. So we've got 12 minus 5 times 2 divided by 2 minus 4. And there's some negative numbers in there, I think. So how do you think that will work out? So 12 minus... Yeah, good, Stephen. And you put in your working as well. That's what I like to see. So yes, good. So 12 minus 10 is 2. And then we've got 2 minus 4 is minus 2. So 2 divided by minus 2, minus 1, or negative 1. Perfect, good. So we've got the same number top and bottom, but because the signs are different, the answer is negative. Okay, this one. So we've got 2 brackets here. So we'll work out the 2 brackets first using order of operations. So in the first bracket, we've got 4 subtract 2 times 3. And in the second bracket, we've got 1 plus 8 divided by 2. So work out the 2 brackets first, and then add the 2 things together. What do we get for this one? I'll give you a second to work it out. We're going to be practicing negative numbers here as well. So, for this first bracket, we've got 4 minus, remember you do multiplication first, so 2 times 3, 4 minus 6 in the first bracket. And then in the second bracket, we've got 1 plus 8 divided by 2 is 4. So, 4 subtract 6 is going to give me negative 2. And then negative 2 plus 5 is going to give me, I think everyone in the chat box, Emmanuel and Stephen, 3. Good. Good, perfect. One more. So this is one with a dividing line again. Now this time we've got 36 divided by 13 minus 4 on the top, and 14 divided by 2 minus 9 on the bottom. What do we think, guys? So let's see. So on the top we've got 36 divided by 9, which is 4. Get into the habit of writing things down when you work it out. No one's expecting you to work anything out in your head, so do jot it down. And then on the bottom, we've got 14 divided by 2, which is 7. And then 7 minus 9 and minus 2. So 4 divided by minus 2. So what do we get? Signs are different, so it's a negative number. And 4 divided by 2 is 2. So minus 2. Okay. If you want to practice some questions, here we are. We're just reaching the end now. We've just about reached the 1 hour mark for the recording. Can't believe I got through all that in 1 hour, and I've covered loads of stuff. Don't spend more than a week on this stuff, by the way. This is just basic arithmetic that you need to know to get you through the course. Or panic that if you can't do this, you won't be able to do other things. Just get a feel, do some practice. You will have plenty of opportunities to work through the rest of the course to practice this. So here's some more order of operations questions for you to practice. There's some examples in the textbook as well. Just do questions 1 and 2. Don't worry about the rest of the exercise. That should be enough practice for you. So questions 1 and 2. And even if you plan to do higher tier, just do the ones in the foundation tier book. I think that the questions are the same in the higher tier book if you do those 6 same exercises. If you want more practice, you could get a copy of this book, which is the Foundation Tier Workbook, which you can buy very cheaply on Amazon. If you buy a used copy, they're very cheap. And I would work through the word rule problems on page 2 and negative numbers on page 6. One thing I like about this book, let me just give you a link to it here. One thing I like about it is you can just write your answer in the book. So I think that's quite helpful because you can just carry the book around with you if you're on the train or in your lunch break and you just want to work through a few questions. That would be helpful. So I'll just give you a link to where you can get this on Amazon. And if you find the textbook really too difficult, so if the textbook is really a bit too advanced, because a lot of the questions are harder than the actual GCSE, or you're really rusty, or you really don't know the basics. It might help to get a Key Stage 3 book. The Key Stage 3 book really is almost the same content as Foundation to GCSE, so if you wanted to work through the Key Stage 3 book first, that would cover most of the things you need to know for Foundation to GCSE maths, so you wouldn't have to repeat the work. So if you're really not confident, and I know a lot of people who are just starting this course aren't very confident with maths, I think that would be a good place to start. So if you wanted to get the Key Stage 3 book just a bit simpler, you could try that. It won't waste your time. And then another very good place to get some practice questions, I would say that this would be Maths Genie. So in the grade 1 to 2 section, if you go, let me just give you the link there. As I said, people watching the live version, I'll paste you these links into an email. Everyone else, make sure that you open the chat box. So click on view, click on chat, open the chat box, and then you can access the links or get them if you're watching the YouTube version. They're in the underneath the video. Okay, so I would go to Maths Genie, and then I would go to try these addition, subtraction, multiplication, division questions, and also negative numbers and bit maths. They're in the 1 to 2 section. So that's about everything from me for today. I hope you enjoyed the session. Anybody want to ask me anything before I let you go? Next time I will be going through properties of whole numbers. So I'll be introducing you to squares, cubes, roots, primes, factors, multiples. Just an introduction, because we go back to all of those topics later on in the course. It corresponds to, I think, chapter 4 in the textbook if you want to start reading ahead, or you can go into the study plan or into your course materials and watch the recording that I did last year, or come along and join me live. Thank you so much. If you would like to give me some feedback, if you enjoyed the session, you can go onto the Trustpilot website and leave me a quick review. You don't have to use your full name, but please do mention my name so that I get some credit and other people know that it was me that did the session. So feel free to leave your feedback there on Trustpilot, and I look forward to seeing you next time. Take care then. Thanks for joining me, and goodbye. I'm just going to leave you with contact details, just in case you do need to get in touch. If you think of something after the session, then you can contact me there. Amanda, the next session will be on Tuesday evening next week. But you can look at the schedule. I sent the schedule in the invitation to the webinar, so if you look at that, I haven't got the link right now, but if you click on that, it will tell you it's at the end of the resources section. It's also right next to where you clicked to come to the live session. There's a link to the schedule. So if you print that out, I've got the schedule for the whole year. You'll see when all of the sessions are, and I'll be covering when. Is that all right? Any more questions? Okay. All right, thank you very much then. Bye-bye.